The Portuguese National Laboratory for Civil Engineering is a world-renowned research institution founded in 1946 as a state research institute with the mission of developing applied research in the field of civil engineering and connected areas. Over the last 7 decades, LNEC has conducted research projects and consultancy work in more than 40 countries, in all continents. DHA, the Hydraulics and Environment Department, was established in 1948. It is composed of a highly qualified team of researchers and technicians who work together to address a wide range of challenges related to the water cycle. Research and consultancy at DHA covers water resources management, coastal management, hydraulic and maritime structures, urban water cycle, groundwater, and information technologies applied to water and environment challenges, aiming to contribute to the water and environment sustainability within the climate change context. DHA holds unique experimental facilities for physical modeling of dams, ports and other maritime, hydraulic, and hydrogeological structures, for water quality characterization, and lab and pilot plants for development and optimization of conventional and advanced water treatment, as well as state-of-the-art research capacity to develop and apply numerical models and forecast systems in all hydraulic and water-related environment fields. Over the years, DHA has built a world-renowned reputation in the field of hydraulics and environmental engineering, evidenced by a vast number of scientific papers, technical reports, and books in a broad range of topics, and their expertise has been sought after by governmental agencies, water management bodies, research partners, non-governmental organizations, and private companies around the world. Nowadays, the department's research covers a broad range of topics. In the domain of coastal and estuarine management, studies are carried out on waves, tides, currents, sediment transport processes, and biogeochemical processes in coasts and estuaries. This assists in the development of solutions for coastal protection and rehabilitation, management of the coastal risks of erosion and flooding, mitigation of climate change impacts such as sea level rise in coastal cities, stability of tidal inlets, improved design of estuarine, coastal and submarine infrastructure, and assessment and prediction of water quality. These studies are mainly developed using advanced numerical models, supported by in situ measurements. Another important area of expertise is the development of effective solutions for the design and management of ports, and the safety of marine transportation. To this end, a huge testing hall with an area of 6,500 square meters, mostly occupied by wave flumes and basins, is used to test under-scaled physical models of waves propagation over real sea bottom configurations and their interaction with marine structures, sediments, and ships. Wave generators are used in those flumes and basins to generate the wave conditions that are the main driver for those studies. The facilities also include a large sediment transport flume and several smaller flumes capable of simulating the movement of sediments in rivers, coastal areas, and offshore environments. Under the subject of the hydrology and water resources management, studies of the hydrological cycle, drought and water availability, flood risk management, and the impacts of climate change on water resources are carried out. Also, the development of innovative solutions for managing water resources sustainably are based on advanced modeling and data analysis techniques. Several experimental facilities are used to support these studies. For instance, to study the flow characteristics and its interaction with different types of hydraulic structures, as well as to test the performance of different designs. Several large-scale models of hydraulic structures such as dams, spillways, and channel are used. Those are nowadays complemented with advanced numerical modeling. Concerning groundwater, several studies are being developed including field monitoring, laboratory soil column tests and large-scale aquifer infiltration and contaminant leaching tests. The structures can also act as a managed aquifer recharge simulator to enhance the quality of secondary treated wastewater during its infiltration through composed soil layers. Most studies developed use numerical models to interpret the current situation and to model future scenarios, helping to support the management options that lead to a more sustainable use of water resources. The research, development, and innovation on urban water systems has a problem-driven approach in the field of public water supply, wastewater and stormwater services and systems, grounded on 4 research lines: water and energy, infrastructure asset management, water quality, treatment and reuse, reliability, safety and resilience of urban water systems. It is focused on the production and transfer of knowledge, methods, and technology to the urban water sector, aiming at increasing the service's effectiveness, efficiency and sustainability, and pursuing the anticipation of innovative solutions to the current and the emerging challenges such as ensuring high-quality services at affordable prices, now and for future generations, promoting the circular economy and the efficient use of resources, particularly water and energy, the system's adaptation ability and resiliency towards rapid and severe changes exacerbated by climate change, and the control of contaminants of emerging concern. Environmental impact and risk assessment research helps projects to be designed and implemented in an environmentally sustainable way, foreseeing the potential effects that different solutions, or even activities, may have on the environment, namely on water quality, soil erosion, and habitats. New approaches are considered to protect, sustainably manage, and restore natural or modified river, estuarine, and coastal ecosystems. The study of hydraulic infrastructures and water bodies' vulnerability to climate changes is achieved within a climate change adaptation research topic, which, overall, ends up being present in all lines of research. This research encompasses the studies on floods and droughts, sea level rise, and wildfires, aiming at developing intelligent systems for risk and emergency management, including early warning systems and adaptation strategies to mitigate these impacts. The integration of all these research areas is promoted by the IT Research Group, through information technologies and computational applications to address current and future societal challenges. Research areas include real data monitoring and real-time forecasting systems, WebGIS portals, artificial intelligence models for data quality assessment and water dynamics prediction, and IT services to address societal problems such as flooding, water body contamination or risk management. These sophisticated tools aim to contribute to a better understanding of the complex water dynamics and to the development of innovative solutions for the sustainable management of water resources. Today, the Department of Hydraulics and Environment of LNEC continues to be at the forefront of research in the field of hydraulics engineering and environment. Over the years, the department has participated in many relevant projects, with a strong external funding support from national, European, and international sources. It has also played a key role in the design of several high-profile engineering projects and other reference studies, such as the General Drainage Plan for Lisbon, the Foz do Iguaçu and Sable Dams, the Alquiva Dam in Portugal, the Cahora Bassa Dam in Mozambique, Sine Harbour, and Tagus Estuary, to name some. Also worthy of mention are the various actions to support the construction of works interventions in the natural environment through the application of numerical models. It has developed many IT-based tools to address current and future societal challenges. Examples include Open Coasts, OSOM, Hydrolerta, Worsica and Mosaic services, most of them freely available to access to anyone, following an open science vision to better serve the society. Indeed, DHA intends to continue playing a key role in society in general, addressing some of the main challenges of the 21st century, such as climate change and anthropogenic interventions, impacts over water scarcity and contamination, risk and sustainable development. Some key areas for future work include developing strategies and solutions to support communities and infrastructure to adapt to the impacts of climate change. These include sea level rise, flooding, water scarcity and water quality deterioration, forest fires, coastal erosion, and changes in rainfall patterns. Another concern is the development of new approaches for the sustainable management of conventional and alternative water resources, namely those that can cope with the binary of increasing demand versus decreasing availability and decreasing quality versus increasing water quality requirements. New methods for assessing the environmental impact of infrastructure projects and land use changes, and for designing measures or solutions to mitigate negative impacts are also envisaged, as well as the development of innovative solutions. Nature-based solutions are a promising concept for climate adaptation and resilience enhancement that need further development. And covering all these areas, research in emerging technologies such as artificial intelligence, remote sensing and big data is included to improve the accuracy and efficiency of the studies undertaken. In the future, DHA will continue to merge innovative research and cutting-edge technology, taking advantage of its multidisciplinary knowledge and capacity to integrate multiple sciences into innovation.